Hello, welcome to the demo. I'm Solan Liu, Director of Digimango Smartware. Today, I'm going to demo using Digimango XML ETL suite in a real-time synchronization between an Oracle database and a MySQL database, which are separated by the Internet and firewalls. You will see that any change done on the source database will show up in the target database in a matter of seconds. In this demo, both the source Oracle database and the target MySQL database are on the same demo PC. The DB2XML engine would extract data from the Oracle database and FTP it to the FTP server in the cloud. Then the XML to DB engine would download the XML file from the FTP server in the cloud and upload it into the target MySQL database. Because of this round-the-globe travel, this demo has the same effect as this structure, where the source and the target database are separated by the Internet and two separate firewalls. Now let's have a look at the source Oracle database. It has two little data tables. One is called department with 4 records. The other is called employee with 8 records, and they are linked by foreign key. The third table, ETL SCNs, is used to make sure that every time the synchronization happens, only the changed data, not the whole database, is sent to the target database. Oracle has a system change number, which we call SCN. Every time a change is committed, a new incremental SCN is created, and all records involved in that commit are stamped with this SCN. Therefore, if we know in last ETL the maximum SCN that we have synced across is 1000, then we know that in this ETL we will only sync across records with SCN greater than 1000. This column, last synced SCN, it stores the maximum SCN that had been synced across when the ETL process was run last time. This column, SCN to sync this time, it stores the maximum SCN that are to be synced across in this run. At the beginning of this DB to XML ETL process, we set this column to the maximum SCN in the system. All the select queries that we are going to run to retrieve data will have a filtering condition to get records with the SCN in between these two SCNs. This way, even if there are multiple select queries to run in the ETL process, and new changes are happening during this ETL process, it is guaranteed that all select queries will be selecting from the same snapshot. Now let's have a look at the DB to XML mapping specification that's going to be used by the DB to XML engine to retrieve data from the source Oracle database. As you can see here, there's an initializing DB command and there's a finalizing DB command. This command will be run by the DB to XML engine at the very beginning of the ETL process, and this command will be run at the end of the ETL process. Here you can see it's quite simple. You first check whether there's one record in this ETL SCN's table. If there isn't, it will insert a record with this latest SCN in the system. And if there's already one record, it will update that record with this latest SCN in the system. And this latest SCN will be stored in the SCN to sync this time column. Then two select queries are going to be run against the database to retrieve data, and you can see it's actually a filtering condition which basically says every rows that we are selecting, its SCN must be greater than last synced SCN and less or equal to the current maximum SCN. And then when the two select queries are run and the DB2XML engine generates XML, at the end of the ETL process, it will update this ETL SCN's table and set the last synced SCN to the maximum SCN that we have just synced across. So this is how the whole thing works. Apart from the two select queries and the initializing and finalizing command, this DB to XML mapping specification also specifies the structure of the XML that we want the DB to XML engine to create. So, and by using this attribute, we map the select query, which is called department and employee. We map the two queries to the XML structure, and the rest of it, the DB2XML engine will work out all by itself how to map the related queries to the XML structure and create the XML structure. Another file that is involved in this DB to XML process is this ETL config file. It basically tells the DB to XML engine to log all messages into this log file and ignore messages with a significance below attention. It also tells the engine to send the warning and error messages to this email address, and it's saying ignore anything below attention level. And then it tells the engine to save the generated XML file as this file in this location, and then zip it and then FTP it to this FTP server in the cloud. It is a well-known FTP server called Drive HQ. The folder on that FTP server is real-time sync. Now let's run this DB to XML process once to generate the XML. First we go to the source Oracle database and we delete this row in this ETL SCN's table. This would cause the DB to XML engine to retrieve all data in the whole database to generate XML. Then we go to the FTP server in the cloud. We use FileZilla as the FTP client, and you can see We're now connecting to ftp.drivehq.com, active server in the United States. Connect. And we go to the real-time sync folder. Make sure there's nothing here. Now let's run. Now let's go to this FTP server and refresh. You can see a zip file is uploaded to this folder. And let's go to this folder. This is specified in these FTP settings, the folder where the sent files should be moved to. And sent folder, you can see there are two of them. One is from previous test. Now let's have a look at the target MySQL database. It has the same department and employee data table, and it has two stored procedures to import the records from the XML into the department table and the employee table. Let's have a look at the import employee store procedure. It has some basic intelligence. It first selects by employee name. If the record with the same employee name already exists, it will update other fields. If the record does not exist, it will insert a new record. Now let's open a second instance of the dgmingo XML ETL switch. Let's open the XML to DB mapping specification. It has declared two store procedures, which we have just seen, and this is the XML data structure that the XML to DB engine is to handle. And here we map the two store procedures to different places in the XML data structure. That's all you need to declare, because the XML to DB engine is very intelligent to figure out the rest. Now let's open the XML to DB ETL config. Same stuff, declaring a log file. Here we didn't declare the email alert, but we can do it if you want. Here we're saying connect to the same FTP server, go to the same folder, download the file, save it locally to this folder, and after the file is processed, imported into the target database, move the file into this archive folder. Now let's manually run this XML to DB process once. Before that, let's first go to the target database and let's truncate the two tables. And then we see there's no record here. Let's go to the FTP server, do a refresh, make sure the file that has been uploaded by the DB to XML engine is still there. Then we go to here, we say XML to DB upload. Done. First we go to the FTP server, do a refresh, the file's gone. Then we go to the target database, we do a refresh, the record appears. Now let's start the automatic synchronization process. First, we go to the DB to XML engines send folder. We delete the files in previous run. We go to the DB to XML instance. We say tools run ETL tasks repeatedly. 0 means run once, so we just increase it to 1 second. It means the DB to XML process will be run every second. Start. Then we go to the XML to DB instance. We do the same thing. Start. Okay. So we have a look at the target database. It's the same because I haven't done anything in the source database. Now let's go to the source database. Employee table. Let's play with the badge number. Let's append some ones to John's badge number. 111. Commit. Now let's go to the target database. Oh, sorry, here, target MySQL database. Do a refresh. 1111 appears. A few seconds. Just remind you, this is a around the globe round trip. Now let's go to the source database, make more changes. Let's append some tools to ND. And then let's add a new record. We call it employee ID. We say it's 9. The name we say Flan. Batch number we call it 1 2 3 4 5 6. And department let's say 2. And we say commit. Now let's go to the target MySQL database. Do a refresh. Appears after only 2 or 3 seconds. That's all for this real-time synchronization across the internet demo, and I hope you enjoyed. Thank you.